This video will explain some of the concepts of port forwarding, which is used to achieve direct access to your Synology NAS over the Internet. Port forwarding is necessary to use some features of a Synology NAS over the Internet. However, many features can be used over the Internet without performing port forwarding, using Synology's Quick Connect service. Some examples of features that will require port forwarding for Internet accessibility include streaming HD video with Video Station or DS video outside of your network, running a mail server or website, operating an FTP server, or hosting a VPN server. Depending on how your network is configured and whether you have a compatible router, Disk Station Manager may be able to assist with configuring port forwarding rules on your router using the Easy Internet Wizard. However, if you do not have a compatible router, or if you have a complex network configuration, manual port forwarding may be required, which we'll cover in this video. If you're new to port forwarding, it can be overwhelming. Instead of jumping into the details to start, I'd like to show you an example of a port being forwarded. In this case, I will forward port 5000 to the disk station, which will enable direct access to Disk Station Manager from the Internet. First, I'll get my disk station's IP address using find.synology.com and make note of it. Next, I'll log into the router with my web browser. In the router's port forwarding menu, I'll add a rule telling the router that requests from the Internet on port 5000 should be sent to the IP of the NAS. Once the rule is saved, that's all there is to it. I can now use my Quick Connect ID, DDNS address, or public IP and get direct access to Disk Station Manager. We'll go over DDNS and public IPs later in the video. As demonstrated, setting up a port forwarding rule is fairly quick and easy once you have the information needed. Unfortunately, not all routers use the same management interface, as shown in these example screenshots from other router management pages, and different router manufacturers may not use the same terminology. For example, port forwarding may be called pinholes. The rest of this video will cover basic port forwarding concepts, how to find the information you'll need to configure port forwarding on your network, as well as some common problems and troubleshooting information. Our first term is external IP or public IP. This is an address provided by your Internet service provider that can be reached by any Internet-connected device. Typically, only one public IP is provided to each customer, and this IP may change periodically. In this example, we have a computer making a request to access Synology.com. One part of fulfilling this request that happens invisibly to most users is that Synology.com must be resolved to an IP address. This process is called DNS resolution. In this case, the resolved IP address is the public IP address of a Synology data center. Entering either Synology.com or the IP address shown will bring up the Synology website. In this example, we see Synology's free DDNS service being used to provide a Synology.me subdomain. This means instead of having to remember 203.0.113.24 when trying to reach the Synology NAS at home, we can instead use myaddress.synology.me. The reason DDNS, also known as Dynamic Domain Name Service, is important for home networks is that oftentimes the IP provided by your Internet service provider will change periodically. Using the DDNS service on your NAS will ensure that even if the IP address changes, your Synology.me address will always reach your network. Next up is modem. Modem is shorthand for modulator-demodulator, which is a conversion of a digital signal, like the ones being sent over Ethernet connections, to an analog signal, like the ones being sent over a coaxial cable. This device basically just makes it possible to use cable types with long run lengths, like those used by your Internet service provider, and allows you to connect modern networking equipment to it, passing information from one signal type to the other. While this is the basic function of a modem, sometimes these devices can be more complex, which we'll cover in the troubleshooting section. Now let's talk about the router, which is the most important component in port forwarding. The router accepts the raw connection from your ISP and is the device that accepts your public IP address assignment. Routers are also responsible for delegating traffic between devices inside your network, as well as delegating traffic with Internet services. The primary way that routers manage traffic is by creating a subnet. A subnet is formed using a set of IP addresses that are reserved for private networks. In this example, we see a subnet using addresses in the 10 range. However, most home networks will operate in a 192.168.1 or 192.168.0 subnet. The last number, also known as an octet, is assigned by the router. As mentioned, these are private network addresses that cannot be used on the Internet. However, these addresses can be used for communication with devices that are inside your network. A private network is also known as the local area network, or LAN. The connection to your ISP is known as the wide area network, or WAN. The only address that can be used to reach the devices in your network from the internet is the one assigned by your ISP. Your router manages both your local network and the connection to your ISP. By default, your router facilitates all outbound communications by your devices to internet services without issue. However, when receiving unknown connections from the WAN, the router is unable to determine which device in the subnet that it manages that it should send the connection to, and by default blocks the connection. Port forwarding ultimately boils down to giving a router instructions on how to direct traffic from the WAN to devices on the LAN. Next, let's talk about ports. There are two primary types of ports when talking about networks. Physical Ethernet ports are the connection on the back of your devices like the NAS and your router, where Ethernet cables connect everything together. The ports that are most important to port forwarding, though, exist in software, and are usually called network ports or logical ports. Each device has a range of ports starting at the number 1 all the way up to 65,535. These ports can be used for various services like presenting a shared folder or hosting a service like the Disk Station Manager interface. This brings me to the core topic of the video, port forwarding. In our earlier demonstration, we forwarded port 5000 to the NAS at 192.168.1.145. This means that the router has a rule that WAN connections on port 5000 should be directed to port 5000 on the device at 192.168.1.145, not to any other LAN device that may be running a service on port 5000. The rest of the ports between 1 and 4999, as well as the ports between 5001 and 65,535, are still inaccessible from the WAN. For each service running on ports other than 5000, we'll need a new port forwarding rule. In this video, we've mainly covered a typical network with a basic straight-through modem and a router. On most routers, there is one internet or WAN port that goes to your modem. If you have a combination modem router device, this may be a coaxial or phone cable rather than an Ethernet connection. A router will usually have 4 local area network ports for connecting devices, as well as antennas for wireless devices. As mentioned before, your ISP will assign a public IP to your network, which is handled by your router. However, there is also an address for the router that is used to manage the router within the subnet it creates. In most cases, this will be the .1 address in the subnet, like 192.168.1.1 or 192.168.0.1. Let's go through another demonstration. This time I'll give a more detailed demonstration of the port forwarding process. I'll go over how to determine your router's login information and how to find the ports for services other than Disk Station Manager on your NAS. As mentioned before, you can find the IPs for your NAS and log into it using find.synology.com within your network. To find the IP address of your router from the DSM, you can go to Control Panel, Info Center, then click the Network tab. Usually the IP to manage your router will be the same as your default gateway. Another option for finding your router's IP address is by looking for a sticker on the device itself. This will usually have the default username and password to log in with as well. Lastly, check the documentation that came with your router, or on the router manufacturer's website, which will usually have PDF copies of the documentation in case it has been misplaced. Next, you'll want to determine the ports you want to forward for the service you plan to use. This can be done by referring to Synology's knowledge base or the DSM help. The article titled "What Network Ports Are Used by Synology Services," located in the General category of the Knowledge Base page, has a list of all ports used by the DSM and packages produced by Synology. Alternatively, ports for different services can usually be found in the DSM help as well. In this case, I'll forward the port for OpenVPN 1194 going to 192.168.1.145. This setup was pretty easy, but let's talk about a couple scenarios where you may encounter problems with port forwarding and how to verify your port settings are working correctly. First, let's talk about a network with multiple routers. This is pretty common in locations where internet is an amenity managed by your housing provider, such as a college dormitory, apartment, or condo, or if you're extending a home network using a router instead of a switch. Each router creates its own subnet, shown here in yellow and blue. When a request on port 5000 comes in from the outside, it will hit the router managing the yellow network first. That router will then need a port forwarding rule pointing to the IP that it has assigned to the router managing the blue subnet. Then you'll need to create a rule on the router managing the blue subnet that directs to your NAS. To configure the yellow network's router, you'll almost certainly need to manage it from a device connected directly to that router. If the yellow router is managed by your university or housing association, you may need to submit a request to the administrator of that network to forward a port for you. A couple other instances where this can happen is if you've got a modem that also manages a voice over IP system, or if your modem also acts as a router. Outside of your network, the NAS itself may also have a configuration problem. For example, you may want to enter the control panel for DSM, go to the security page, and verify the firewall is correctly configured to allow access if no rules are matched, and ensure you don't have conflicting rules in place. This can happen with failed attempts to use the Easy Internet Wizard with an incompatible router. To be completely sure that your NAS doesn't have a configuration problem, you can also try resetting your network settings using the knowledge base article titled How to Reset Your Synology NAS in the general category. If you have multiple NAS devices that you'd like outside access to, or simply have other devices using ports that a Synology NAS would normally use, you can reassign the default ports for most services or enable additional ports to access those services. There can also be problems that are outside of your control. For example, many internet service providers block the port for web station or the ports for mail server to prevent customers from running a web or mail server. If you're having trouble with these services specifically, you may want to contact your ISP or assign alternate ports within the DSM for these services. There are a couple ways to test if remote access is working. One way is to test the connection from outside your network to the service you configured rules for. This could be using a cell carrier's data connection while your cell is off your personal Wi-Fi, or from another location like a neighbor's home or an outside office. Another way you can test your ports is by using canyouseeme.org within your network. Just enter the port number you want to test and click Check Port, and it will inform you if the connection succeeded or failed. Signal's port forwarding tester can be useful if you're already outside your network but know your IP address or DDNS address, or if you're inside your network as well. The last issue we'll talk about in this video is network performance. There are a few things to take into account here. First, we'll talk about the LAN. Most modern networking equipment, including Synology NAS devices and routers, will offer a 1000 megabit per second connection, also known as a 1 gigabit per second connection to wired devices. However, wireless connections can vary drastically. The wireless standard known as Wireless N, or 802.11n, may be rated for as little as 54 megabits per second up to 600 megabits per second. Wireless AC, or 802.11ac, currently has standards ranging from 433 megabits per second up to 1,690 megabits per second. These speeds are usually theoretical maximums for a single connected device that aren't typically seen in the real world. However, HD video content won't usually have a problem within your LAN, as most HD videos are between 5 megabits per second and 50 megabits per second. If you are having performance issues in the LAN, be sure to check if a different device achieves better performance, as it may be an issue specific to the device you're using. Another great option is to try a wired connection if you're having problems with your wireless connection. This is particularly true because a wireless connection can be greatly affected by interference from other wireless networks in your area, as well as other electronics like lighting, and some outdated technology can generate interference in the Wi-Fi spectrum as well. When it comes to streaming outside of your LAN, the performance of your LAN isn't as important as the speeds of your WAN connection. While many internet service providers provide great download speeds, you'll be reliant on the upload performance of your ISP when it comes to streaming or downloading content outside of your network. For most providers in North America, upload rates are 10 megabits per second at most on home connections, and are often lower than 10 megabits per second. There are exceptions where upload rates are over 10 megabits per second, though. Be sure to check with your internet service provider regarding your service plan if performance outside of your network isn't meeting your needs. When trying to stream video, consider using transcoding if available with your NAS to lower the quality of the video being streamed. This will be a more compressed stream of the video and more likely to be within the constraints of your provider's upload rate. Remember, port forwarding isn't necessary for most access to your NAS when using Quick Connect. Port forwarding will only really be needed when using certain features, third-party software, or to get the best performance when streaming video. I hope this video has provided a better understanding of your home network and how to unlock its potential for your Synology NAS. Thank you for watching, and be sure to check out our other videos.